Hey folks, welcome back. Thanks for joining me again as we get started on our next lesson, which includes VPC subnets, security groups, and network access control lists. Let's go ahead and jump in. Now, you may feel like we've talked about some of these topics already, but there are some additional things that we really need to make sure that we cover VPCs and all of their associated components. So let's start off talking about subnets. Subnets is short for subnetwork, and it's a subsection of a network. Generally, a subnet includes all of the computers in a specific location, very much like our houses on a street analogy. All of the houses on that street, like we talked about before, are related to each other. They're on the same street, and they each have an identifier that identifies them as houses on that same street. Well, it's the same thing when you think about your home network. It's not a direct analogy, but you can think of your home network as a subnet or a subnetwork of your ISP's network, because your network has to connect to your ISP's network in order for you to get access to different internet resources. So you can think of your house as a subnet, your neighbor's house as a subnet, and so on. And each of you have different devices that are within your home that connect to the internet. Could be computers, could be tablets, could be phones, could be any type of device. But the fact that they're all in the same specific location and they're all connecting either using Ethernet or to your Wi-Fi so that they can communicate with each other and so that they can communicate all to the internet in its most basic terms, that is a subnet. Now, when you think about the AWS definition, when you create a VPC, it spans all of the availability zones in the region. After creating a VPC, you can add one or more subnets in each availability zone. Each subnet must reside entirely within one availability zone and cannot span zones. Also, note that the default VPC has subnets that are created by default. So let's take a little bit deeper look at this. So this diagram shows you that we have two separate availability zones, and those availability zones, we also call them AZs, cross through your VPC, right? Your VPC can have resources in any of those availability zones. Now, when you look at your subnet, in our example, we have a private and a public subnet, and then each has resources within it. So you can think of each of these subnets as separate streets with houses on those streets. Now, it's up to us to determine what these resources can communicate with. What access do they have? So if we wanted these instances to be able to talk to each other, then we actually use the communication through our network access control list. The route table then says where that data needs to go. So it says, okay, we're going to go back through the network access control list over to this other subnet. So you can use the network access control list to control access between subnets and out to the internet, which we've kind of talked about before a little bit. Now, what makes this a public subnet and what makes this a private subnet? And so that's what we're going to talk about next. So public subnets are subnets that have the ability to access resources on the internet. Well, what makes that possible is the fact that the route table has an internet gateway attached to it. The communication from the subnet goes through the network access control list. The route table directs it out to the internet gateway. So the title public subnet does not make it a public subnet. What makes it a public subnet is what rules are in the route table. If you have a route table that has an internet gateway rule associated with that route table, then you have access to the internet. If you have a route table that does not have a rule that points to an internet gateway, then it is a private subnet. Again, these labels do not directly affect whether it is a public or private subnet. What does that is the entries in the route table. So let's now go ahead and take a little bit more of a look at networking security. So we talked some previously about network access control lists, right? So you've seen this particular slide before. And we kind of focused at a high level of how a network access control list behaves like a bouncer, right? How he guards the door like a doorman and determines who can come in and who can't. We talked briefly as well about security groups. Well, in this lesson, we're going to take a little bit of a deeper dive into looking at exactly what the network access control list can do and what a security group can do. So it'll help you to be able to compare and contrast the difference between those resources. So this is a diagram that presents a little bit more about how the data is moving through a network access control list. This is resources for our public subnet, and over here in the blue is the route table and information for our private subnet. So for our private subnet, if we wanted to access resources in the public subnet, this route table tells it, hey, that's local to the VPC, so you can communicate directly with that subnet. But it does not have an internet gateway attached, so it can't send traffic to the internet. Now, the other thing is that it actually is sending through the network access control list. So you can use this network access control list to control communication between subnets. We could, on the public subnet, we could add a deny rule that would prevent any resource in this private subnet from being able to see and access anything in the public subnet. In terms of the rules for the NACLs, think of it like a list, a numbered list. And the number represents the order in which the rules are actually processed. So if you wanted to allow HTTP, that might be rule 10. If you want to deny FTP, that might be rule 20. So you're able to specify the rules so that they're processed in order. Now, what we're doing in this diagram is we're saying we're going to allow HTTP traffic through this network access control list. And that's what we're doing up here. This user is attempting to HTTP or access the website. And as they go through the internet gateway, the route table directs them to the appropriate subnet. But they have to come up on the bouncer, right? So the bouncer says, hey, what's up? Do I know you, right? HTTP says, hey, you know me, we're buddies, right? So I need to be able to access this EC2 instance that's in your public subnet. I need you to let me through. The network ACL checks its list and then directs that communication through to the public subnet, which will then have to be evaluated by the security group. And now your security group also has to determine, should it allow that traffic to enter into the security group and ultimately touch this EC2 instance. For the purposes of this example, let's say that HTTP is allowed, so that communication comes through the security group and you can access the EC2 instance. Now the NACL, or the network ACL, can also block traffic. So here we have FTP traffic that's actually coming through and being blocked at the network ACL. Again, the NACL is the bouncer and it's saying, sorry, you're not allowed to pass. You're not allowed to access that server in the public subnet. We do not allow FTP access. Your name is not on the list. So you can apply both allow and deny rules to a network ACL. Now, the interesting thing about network ACLs is they are considered stateless. And that means that when the return traffic after it goes to the EC2 instance comes back to the NACL in order to get out, to go back to our user up here, the network ACL has to have a rule that actually says to allow that traffic back out. So the bouncer is standing at the door and saying, for both inbound and outbound traffic, let me check my list to see if you are allowed. If you are allowed out, then I'll let your traffic out. So let's go ahead now and take a look at how NACLs work for inbound and outbound. Notice that you have inbound rules and outbound rules. So think of it like we have different bouncers, right? There's a bouncer for inbound and there's a bouncer for outbound. The bouncer stands there with his list and he says, you're allowed to pass or you're not. The bouncer on the outbound, which would be the bouncer here, does the exact same thing. You're either allowed out or you're not. And it all comes down to, are you on the list? Anything that's not explicitly on that list, there's a rule at the end that says block everything else. Now, when we look at our rules again are evaluated based on rule number from lowest to highest. The first matching rule that it finds gets applied, and all of the other rules no longer come into play. So if I have 10 rules and rule number 3 says allow HTTP traffic, as long as there's not a rule before this that says deny HTTP traffic, then the traffic is automatically allowed. It doesn't matter that the rule at the end says block everything, right? So you have to make sure you put your rules in the right order on your network access control list as well. Okay, so let's go ahead now and look at the difference between your default network ACL and creating your own new network ACL. So the default network ACL is assigned to the default VPC. So if you remember, if we came over here and went to VPC and we go to network access control list, there is a default network access control list associated with the subnets. So notice down here that we have both inbound and outbound rules. So if I go to inbound rules, notice that the default one has an allow everything rule and then a deny everything. Well, the allow everything is the first rule. So that's the rule that's going to get processed first. This rule matches, so that's what it's going to allow. So if we go to our outbound rules, we have the same thing. So your default NACL always has a rule in it that allows everything, that allows all types of traffic. That's AWS's way of ensuring that you have the easiest possible setup if you're not familiar with how VPCs work and how all of those associated components work. Now, when you create a new network ACL, everything is denied by default. So let's create a network ACL and we will call this CCP_NACL and select our default VPC and click create. So now if we go here and then go to our outbound rules, notice that it denies everything, right? Same thing for our inbound rules. So we would have to create a rule that decides what traffic to allow when you make a new network ACL from scratch. So I'm going to click edit inbound rules. I'm going to add a rule. Let's just call this rule 100. And I'm going to select HTTP as the rule type. Port looks fine. And here is that default, hey, send everything through this particular path, through this IP address. Now, if you want to only allow certain resources through the NACL, like certain subnets, let's say you say, I only want to allow this private subnet to have access to HTTP. You don't have to allow everything. You can restrict this to the IP address range that's assigned to that subnet. So let's say that the subnet address is 172.31.2.0/24. I'm just making that address up right now. So I'm going to click save. And now I have that rule. Notice it says, hey, HTTP from this subnet is allowed. But if it's coming from any other subnet or if it's any other kind of traffic, deny. And that's inbound only. Outbound, we have a deny all. So if this instance tries to access something over here based off of this rule, what would happen is the traffic will be allowed inbound, but it would not be allowed to exit because our only rule is deny. That's what stateless means when you're talking about network ACLs. So let's take one final look at this diagram. We've talked a lot about network ACLs, but we haven't talked a whole lot about the security groups. We lightly touched on them. The security groups are really associated more so with the actual EC2 instances. Now, I can have multiple instances inside of a security group, but they're associated at that level and not at the subnet level. So that's a key differentiator between the two. So we're going to actually talk more about security groups and how they actually work in the next section when we talk about compute. But for now, know that your network access control lists are stateless and they allow that communication both inbound and outbound. Now, if you come over to the AWS console, you'll notice that you see both network ACLs and security groups here underneath of VPCs. You'll also find security groups on the EC2 dashboard as well. So AWS put that in both locations to make it easier for you to be able to see and access it. But the security groups are more so associated with the instance and not with the subnet. So this is a common point of confusion for folks. So make sure that you're very clear on that. The network access control list is the doorway to the subnet itself, and it decides what traffic is allowed in and out of the subnets. And it's stateless, meaning that you have to explicitly create rules for both inbound and outbound traffic. The security groups we'll talk about again as we get into the next section. So that's going to do it for this lesson on subnets, security groups, and NACLs. Thanks for watching. I'll see you in the next lesson.